Hi everyone, welcome to my shop. I'm Mick. So in this video I'm going to be making a tapping arm, specifically the one that was designed by Billy from Knox Machining. So I'm not going to be going into a lot of details as far as what the specs are and everything else. I'll put a link to Billy's video down in the description, where you can see, which thrust bearings he chose and which tapping arm, monitor arm he chose to buy and base this off of. This is my experience building one, and then a brief demo on how it works. And so let's get started. Alright, let's start taking this apart. So there's a boss on the top of the base there that we'll be removing in a little bit, but the materials that Billy specified include 3 different thrust bearings, thrust washers. So I'm just checking to see what fits where, and trying to form a plan in my mind as to what the next steps are going to be. Alright, so I need to mill this off so that it's just flat. I need to make a bushing. $17.82. I believe these are 20. Yes, 20. Okay. Okay, so we've got this base mounted in the vise, some cardboard to protect it, and this bar clamped down on some 1, 2, 3 blocks to just help keep it down. So no critical dimensions here. I'm just going to mill this boss off until we get down to a single flat surface. Alright, that looks good. Yeah, very nice. Now we need to bore this. Need to bore it out to match the size of the thrust washer. Just going to leave it set up just like it is. It seems to be working pretty well. Alright, so I've got the coaxial indicator mounted in the spindle in a collet, and we're going to center up the spindle on the bore down here, and then we're going to take and open that up to 20 millimeters. So let's set it on low speed and start dialing this in. Right now I'm just doing the x-axis. Looks like that's about right. Now we'll do the y-axis. Whoa, what just happened there? Huh. Big movement on the y-axis all of a sudden. I think that's about all I'm gonna get. I think the rest is just down to surface finish. Alright, set up the boring head. I'm going to lock the X and Y axis, and I'll come back in a minute. Alright, so I've got my boring bar set up to where it's just scratching the inside of that board. I'll raise it up just so just clearing. And let's give it a shot. I haven't done much boring, so I'm going to take it slow and just take small passes until I get there. Alright, I think that's through. Looks like it still didn't quite clean up all of the inside. Alright, and that is at 70. Take it out another, so it took it out 15 or 10, let's take it out 15. See how that does. Alright, that should give me a surface I can measure now and see how much more I need to take off. Alright, so that's 18.23 millimeters, so I got to take it out 1.77. Okay, so I said I need to go out 1.77 millimeters, which is 70, basically 70 thou, and each division is 1 thou. So let's try that again. I'm going to take off 15 thou and see where that leaves me. $18.59, 1.41. I'd say that's pretty good. So let's take off some more. So I know that every 15 thou is 20.08. I'll live with that. Alright, so other than chamfering, this part is done. Now let's move on to the arm. Figure out how I'm going to mount that on the table here. Alright, I'm back. Turns out the arm that I ordered is slightly different, it appears, than the one that Billy used. So the next step I'm going to mill off this boss, just as he did, so that a thrust washer and a bearing can sit there. This part goes right here. So that leaves quite a bit of gap there, and the thrust washers also have quite a bit of gap there. So I'm going to be making a bushing that is inside diameter for this, with a step for the thrust washer inside diameter, and then the outside diameter the same dimension as the outside diameter here, so that bushing will go on the shaft here. The thrust washer will go on. I'm going to need to measure the thickness of the thrust washer to make sure that the thrust bearing, to make sure that I get that right. I'll probably want it just a little bit under. And then the OD of the other step will fit down into this part here to make that a snug fit. Then I'm going to need to do something for the inside. You can see that there. Again, because it's a big loose fit there, and I want to have another bushing on the inside for the smaller thrust bearing to go in there. So I'm going to set this arm up on the mill now. I wasn't sure if I was going to have to bore this opening out anymore like I did for the base. I do not have to. It's already bigger than I need. So all I need is enough clearance. Let's see if I can get you a show here what we're looking at. I need enough clearance here to be able to mill that off. So that shouldn't be a problem. I've got plenty of clearance already, and it can go up another inch or so. Excuse me, but the problem I have now is how to secure this to the table such that this surface is parallel to the table. And I think Billy did it with a V-block and a small machinist vise over here on the side. And the problem with that is that raised it up enough that I don't know that I'll have clearance. I'm going to measure and see if I have clearance there. Maybe I'll just use the same approach. Alright, I'm going to do some measuring and come back. Alright, I think I've got this secured now. There was enough room for, even with the end mill holder, to put this in this way. So I used a very similar setup to what Billy did. I used a V-block and a machinist vise that's clamped to the table down here. So it's clamped on the shaft, so that's held perpendicular to the table. So that's good. I just angled my angle plate in the vise and secured it at the same angle, and then just used a clamp. Billy had a little bit different setup, but this seems to work. It's there, so let's trim that off. Alright, I'm just going to take a very light pass at first, as I like to do, just to make sure that nothing gets screwed up, and then we'll probably take some pretty good sized passes. Very good. Over here. Alright. Usually takes me a few hours at the very least, sometimes days, just contemplating these setups and stuff. But as I do more and more of this, I've learned that it's better for me to do that than to screw it up. So, looks like I could take another hair off of that. I'm going to take another 5 thou off. Okay, so now we're going to make the Delrin bushing. And it needs to be 1.18 inches deep and 1.37 inches in diameter on the big part, with the shaft here being 0.79 inches in diameter and an internal bore of 0.585. So we're going to start by facing this off and then turning down the diameter for the small part here. Alright, this is going to take a lot of passes, so I'm going to do this, and I'll bring you back when I've got this turned down to that major diameter. Yeah, very nice. Okay, now I need to bore out the center and then part it off. Very nice. Alright, so got this joint back together. Just need to put some grease on the final thrust bearing and assemble, attach it to the base, and then this part should be done. Nice. Okay, now I need to make a bracket to attach the tapping head here. I think I'm going to make that out of steel so that I can glue it so it'll be black, but we'll see what I have lying around. I should have enough steel. Alright, so this is the tapping head that I bought for this application. And it looks like I have one spot that I can mount, make a mount for, and that is right here. It means I'll be holding it over the top of the arm, which is not bad. You know, like if I make it just a clamp right there on this round part, Alright, let's get some dimensions and see what we can come up with. Alright, I am super stoked. So I've got the arm done. I decided to just 3D print a mounting bracket to attach the tapping head to the arm. Figured at the very least it can be a prototype, and if I need to, I can make it in aluminum or steel. This is just PLA. I can also print it in carbon fiber plastic. If I want, I might do that. I got so excited that I had actually managed to design this part successfully that I forgot to chamfer a few edges here, so I might go back and edit the drawing and reprint it in some carbon fiber, but I think it looks fantastic. So it works as I would expect. So I've got a vise here that the intent, let me move the camera a little bit. The intent is that this is a tapping station. So I've got the tapping arm here. I've got a vise that I'm going to drill some holes in that I can mount this in various places, and then I've also got this tapping arm that you've probably seen in some other videos before. If I just want to do one or two quick holes, or if it's something that I want to pay a bit more attention to and make sure that, you know, I'm being a bit more careful with it, I've got this. And then of course I can also, so I'll be drilling holes to attach this to the table. And then I can either use this vise or this vise over here if I need to do some manual tapping. The intent is I'll be building storage containers underneath the tabletop here for all of my taps and dies. So yeah, so let's get this thing hooked up to some air. I'm going to run an air line over on the ceiling above here, and have a drop coming down. I'll probably add another regulator over here so that I can dial in the air pressure where I want it for this tool. But in the meantime, let's run a hose over and try it out. I'm excited to see how it works. Got a whole bunch of tap adapters for it. So yeah, so let's try it out. Alright, so I've got a tap in the tapping arm, got the air hooked up to it. Like I said, I'm going to run a dedicated line over for this. I don't like this big heavy line hanging off of here. I do not have the vise secured down yet, so that'll be next thing to do. But I picked up a bunch of these tap holders for this, and yeah, I think I'm liking this so far. It's pretty cool. You just push here to release and the tap comes out. Got to push it in to seat it, but it locks it in there. And similar arrangement on the tapping head itself. You just pull up on this collar and the whole the tap head comes out. So let's give it a shot. I haven't tried it yet, so it may work, it may be a failure. This is quarter 20. Okay, a couple lessons learned there. It's not tight enough in the arm, the holder that I made. It looks like it tapped it pretty well though. this is, I believe it's 1018 steel. So this is not a simple test. Yeah, I think I'm going to end up making a mounting bracket for it out of steel or aluminum. Plastic's good for a prototype, and I kind of like the design, but actually pulled it out of alignment there. Yeah, it's loosening up already on me. Alright, good for a proof of concept, I think. Yeah, that definitely needs... Maybe if I printed it solid. So this part here, if you can see that, this part here that attaches to the arm, it's not solid. It's got a 15% infill. So I think maybe if I print the thing solid, try printing it out of carbon fiber. Alright, well, I think we're well on our way. Figure out if I'm going to make one out of steel or try another experiment of printing. All I need to do is change the infill setting on the slicer, so I think I'll try that, and maybe at the same time hose is pulling on it, and I don't like that. I gotta get a better hose for this setup and hang it from the ceiling, and then maybe put like a thin sheet of rubber here between the clamp and the body, because it's smooth machined aluminum. But a couple adjustments, and I'm going to call this a success. I think I'm going to make up a rack for these, so I've got them all labeled, and get the holes drilled in the table. So one thing I wanted to point out is the reason that it lifted the part up out of the vise is because these are through holes, and I just stuck a piece of metal underneath, and it hit it and pulled the whole part up out of the vise. So it was nothing because of the tapping head or anything like that. It was just the way I had it set up. Yeah. Alright. 2 thumbs up. Alrighty. Oops, sorry. Alright, everybody, take care, and thanks for watching.